All right. So it's very nice to see that we are so many people here. So just to quickly run through the Swedish Geological Survey, we are the national authority for geological, mineral, and groundwater issues in Sweden. Most of us are geologists or engineers or hydrogeologists, scientists in general. We are a national government agency, so we work from a lot of places in the country. Myself, I'm in Uppsala right now. It's extremely dark here in the north, and it's been dark for quite some time. So I'm envious of you. Many of you I see come from Italy. I'm quite envious of the light you have there, and maybe a bit more warmth. Here's snowing currently. So some of the things we do is to increase and promote geological knowledge. We work with strengthening the geological expertise in the country and so on. Myself, working mostly with the mining industry, I work with promoting sustainable growth in the mineral sector, as we have a lot of mines here in Sweden. And continuing on, a few of the educational projects at SGU, we do work with all ages, really, with geology, and going to the lower ages, we work with Minecraft, mostly for children and young adults. And we also have some initiatives for high school and so on. Armament schools is one of them. We work in the Armament Schools Consortium and also in the Consortium for Armament Schools and Southeast Europe. We have some additional initiatives for public awareness and for professionals. As I said before, I work in an international training program for government professionals in Africa mostly, but we also have some things about public awareness. I recommend you to check out Mind Facts, which is a fact collection about exploration, mining, and sustainability for the public. Moving on, the topic of today is teaching about Minecraft, teaching with Minecraft especially, and here we use our modification called BetterGeo, and we also have an additional EU project called BetterGeo Education, which I'll talk about soon. But before, maybe some background. So why did a government agency in Sweden create a Minecraft modification? That's maybe one of the questions I get most. And it dates back to 2013, where we got a new mineral strategy, a document released by the Swedish government with a lot of different objectives. One of the objectives was to increase the public's knowledge about the significance of geology for development and growth. And this project lasted from 2014 to 2016. And there was a lot of different objectives in this very large document, but this objective and this project was maybe the most one of the biggest ones, and maybe the ones that were difficult to approach, because it's increasing the public's knowledge, like the whole of the public, and it's a very big, very large aim. Like there's a lot of people in the public. It's like 10 million people to reach. So what we did, we created a lot of small projects within this large project, and so we tried to do 3 different types of categories. So one for schools, one for the public, and one for job seekers. That was the objective in this project. And one of the smaller projects financially and time-wise was BetterGeo. And this was categorized under the public, as we initially started to work with children and gamers and parents and so on, not in schools, but rather in the public as a whole. And I'll go through that soon. But Later on, we realized that this could be a very good tool for schools. So we expanded that towards schools later. So I'll go on with that background soon. But just for you to keep in mind, the way we developed this tool was mostly for the public in general. So backing up a bit, why did a government agency start to do work with games and stuff? It was also one of the questions I get a lot. So we really wanted to meet the target group, which was kids and young adults, where they were themselves, their own arena, basically. So we know that a vast majority of children from age 2 and up, they play video games daily. And this graph is from Statista taken last year, and it shows a Western country, the United Kingdom, how many hours children play games each week. And you can see that moving up the ages, it gets more and more and more. And generally, kids aged 12 to 15, they play games for almost 14 hours a week, like average. So there's people playing even more than that. And so this is a huge, for me at least, is a huge untapped resource. Like people playing games all the time, but could we do something more with this? Could we use this love for gaming to maybe learn something at the same time? So that's where it started. So there's a thing called gamification, which in essence means the application of game design elements and game principles in non-game contexts. So for example, schools, which is a non-gaming context, where you can add the application of game design elements and game principles to increase the user engagement. So things like, for example, the feeling of achievement, such as challenges or gathering points or filling progress bars or reaching new levels and so on. It's been used a lot in education and schools to improve the user engagement. And storytelling, I'm sure you know, to have choices, to create fantasy and creativity is a great tool to use when teaching. And cooperation and competition, I think stands for itself with teamwork and maybe sometimes leaderboards and so on. It can be a great tool to use in education to learn more. One of the most well-known applications, educational applications, is Duolingo. I'm sure you know of it. It's an app where you learn different languages, and here you can. It uses gamification in a lot of ways. So, for example, you can have a streak where if you use the app for a lot of days in a row, you get a streak, and you can add scores. And going through the language lessons, you actually gather points, and you go down kind of like a progress bar in sorts of ways. So it's a really successful way to show that gamification, it really works in educational themes. Another thing that isn't really associated with gaming is going out to run. So another app is Zombies Run, where you in your earphones while you run, with this app you get a sort of a story running. And the story is that the world is now in an apocalypse. There's zombies chasing you, and you need to gather some different materials and so on. And the story, while you are running, it tells you to run faster and run slower because there's zombies right behind you and so on. It's an easy way to use storytelling to really help you to run like faster and longer and so on. And really increase the engagement that you have during your running session. Another one, very simple, LinkedIn. I'm sure many of you use it. While creating your profile, you are engaged to increase your profile strength. And here you have progress bars, for example, that help you to add different skills and so on, add more information so that LinkedIn knows more of you than before. So this is another way of using gamification. And there's also, in a sense, more leaderboards and so on that you can use in a gamification sense when looking for jobs and social media and so on. So these are 3 tools that are using gamification. While we might not realize it, it's using game elements and game design to help us engage more. So it's a really interesting thing. And why is this? So in general, games, they increase our learning potential. So games are made to be enjoyable and fun. And if they are more enjoyable and fun, then they become more memorable. And I think Judy Willis, she puts it very well in this this quote I put here. So when students are engaged and motivated and feel minimal stress, information flows freely through the affective filter in the amygdala, and they achieve higher levels of cognition, making connections and experience aha moments. So this is the neuroscience of everything. It's how the brain works. It actually becomes more, if you are engaged and you're motivated and so on, it actually helps the brain to remember things. So games can be extremely powerful when it comes to learning. I'm sure that at least from my personal experience, I remember very few things from my early years in schools, but the things I do remember is because they were very fun to me. They were very engaging and very fun, and thus they were very memorable, and I still remember them to this day. So I think that's a very powerful thing. So okay, Pontus, the gamification, we get it. It's good, but again, coming back to why did a government agency make a Minecraft modification? So again, we wanted to have a way to disseminate information and easy knowledge about raw materials, circular economy, and sustainability, very important things to the general public. And by reaching children, we believe that we also reach the parents. That's why we put this under the, if you remember in the beginning, I put it under the public category. And we know that parents, they pay attention to the games that the children play. They talk to the children, and discussions in the lunch table and so on is very important for knowledge exchange between children and parents. And as you see here, 90% of parents, they pay attention. So this is an important part, that we could use the children to also reach the parents. So it was a really powerful tool that way. And we knew that Minecraft is one of the most played games in the world, with 110 million active players each month. So it's a really huge thing. So, and in addition, which I'll speak on soon, is it had a really good modification support for players and by players. So it was really easy for us to motivate this initiative to other governmental agencies and so on, why we did this, because yeah, but back in 2013 and 2014, this was quite, it was a few years ago, so it was quite new still. It was unheard of that a government agency made Minecraft or gaming stuff. It was really weird, but still people believe that it was good. So Minecraft. I'm sure that if you are sitting here right now, we have 88 participants right now. I'm sure that many of you know what Minecraft is. And I do many lectures and workshops and so on for kids. We go out talking to classes and so on. And almost every time I ask how many of the kids know what Minecraft is, everyone raises their hand. It's really a huge phenomenon that almost all kids know about. And this is because they either play it or they they enjoy watching it on YouTube, or they have a friend playing, or so on and so on. And the game itself, it's in the name, it's about mining and crafting. So one of the most important things is mining for raw materials, and that's why we are here today. We are talking about raw materials. This is a EIT raw materials project, so it's in the name there also. So in the game, if you didn't know, you are in a 3D world made of blocks. They are raw materials for you to mine. You are set out on an open world where your task is, you don't really have a task, but if there's any task, you should survive, and you should build things. You should craft things with your raw materials to survive and to build amazing things. So, and there's monsters during the night and so on, so you have some extra challenges there. But the problem with Minecraft is that it's the geology in the game is quite simplified. So we know that the game is about geology. It's about mining for raw materials. That's one of the main things that you do. You get these raw materials so you can make tools, you can build buildings, and so on. And what you do in the game, if you don't know, in the original version, to get the most raw materials, is that you dig down, you dig as far down as you can until you can't dig anymore. And there you do these almost like a strip mining. You make holes like this, and you search for raw materials. And in that way, you can find as many raw materials as possible. That's the maximum value you can have for your time. And here you can find, for example, you can find gold, there's diamonds, there's redstone, there's iron, there's obsidian, there's gravel underground, there's coal, and so on. And they all clump together in the same place, basically. And as a geologist myself, I feel like, well, this is not really realistic. It's great that we get to know about gold and diamonds and iron and all of these raw materials, but it's not really realistic. In a real world, we don't just dig down as far as we can and then find all the raw materials we need. We look in different environments, we look in different types of rocks, we find different minerals and so on, and we process them to find the raw materials we need. So it's really a much more complex system than that. So really what it boils down to in Minecraft is two things, and it's stone and it's dirt. That's what most of the world is built of. Some gray block that is called stone, and some brownish thing that is called dirt. And again, as a geologist, it's kind of provocative when you simplify it so much. So really what it ends up to be is a extreme simplification of reality, where you have these gray rocks and this brown dirt and so on, and there's not much more. What we wanted to do instead was to change this, so we have a lot more diversity in the world, and introduce new realistic rocks, introduce stratigraphy into the game, real ores, real minerals, real raw materials, new soils, and so on. And what we end up is the same game, same randomly generated worlds and so on, but with a new, more realistic generation, and more rocks and so on. And it can look like this. You can see the obvious change. It's the same map. It's the same thing, but it's more diversified. So what was called stone before, in the original version of Minecraft, is now with our modification. And a modification, again, if I should explain, it's basically like something you add which modifies and changes the game. It changes different things. You can, for example, have modifications that add new things, or it changes things, or it takes away things, and so on. Our modification is quite large, I would say, in regards to some others, and it changes mainly the geology. So what was called stone is now new realistic rocks. So we have, for example, this gabbro, this granite, this basalt, pumice, this kimberlite, this diabase, and so on and so on. There's a lot of new raw materials, I would say host rocks for raw materials. We have realistic ways to find raw materials. So for example, diamonds, in the real world, you just don't go as far down as you can and find different raw materials. And diamonds, you look for kimberlites, which is a certain rock that we find, for example, in Russia, in South Africa, and other places. And it's extremely rare and very special. And here you can find diamonds. There's iron. Again, it's not just next to the diamonds, deep down in the earth, and it's not next to the gold and so on. You find them in banded iron formations in BetterGeo modification. Titanium, copper, you find in gabbros. There's coal to find in sedimentary rocks such as limestone and sandstone and so on. So there's really a new way to find different kinds of rocks. Dirt was another thing that we also changed. Instead of dirt, we modeled the soils to really, in the beginning, a Swedish environment where we have a lot of glacial remnants and quaternary rocks, quaternary soils, rather. So there's clayey tills, the different types of tills, blocky tills, and pebbles, for example, marking the highest coastline. There's peat, there's bauxites in tropical environments where you can find aluminum, for example, glacial erratics, mulch, and so on. So you can use different types of things to do farming. Farming is a rather important thing in Minecraft, and this way we could show that different soils are good for different things. So, for example, it's very good to do farming for wheat, for example, in a clayey till. The clayey till has a good amount of nutrients, and it holds water very, very well. So the things that you farm would grow much quicker than in a blocky till, for example, that has huge boulders in it. So things wouldn't grow as well there. So that's one thing that we added. New raw materials. Again, I said it so many times. It's a very important thing. We've added a lot of new materials: the zinc, copper, aluminum, tin, tungsten, lithium, and all of that. There's rare earth elements, there's gemstone, there's different things. But we also added a way to find these raw materials. So, for example, there's a magnetic compass, which you can use as a prospective tool, exploration tool, that actually starts spinning when it's close to something that is very magnetic. So and banded iron formation, for example. So you use the magnetic compass to find iron-rich ores. There's an electrical conductivity meter which you use to find things that conduct electricity very well. For example, copper. So you can find skarns and different copper mineralizations with the electrical conductivity meter. It becomes an exploration tool. In Sweden, there's some flowers that grow called alpine catchflies. They're also in other parts of the world, which actually grows on top of copper-rich soils. So if you find these flowers, you can actually deduce that there's copper in the ground below. So it's a good thing to also find. Industry and environment is also very important. We know that processing ores is not as easy as just putting them into a furnace and then taking out the metal. So here instead you have a smeltery, which is a lot more complex, where you actually use different types of you can see how we use different amount of energy for different types of raw materials. So for example, something like aluminum, which takes a lot of energy to process, you need to put in more energy into the smeltery and compared to maybe iron, which is easier. There's also alloy furnaces, and you can make different alloys. And we also know that there's environmental issues connected to industry and mining. So we added, for example, slag and ash and so on, which is produced around the place. And you can actually use different innovations to help with this, such as a flue gas cleaner, which is a chimney that you put on top of your smeltery to help with the ash that produces. So, but it takes a bit of raw materials to build those also. Again, all of this is well and good, but if you have all of these raw materials, you also need something to make it interesting and something to build with. So here we added a lot of different new items, especially things that make it more fun to play, basically. And we couldn't really add like mobile phones and laptops and so on, like real items, because they don't make sense in the game, really. So we added things that would be fun instead. So for example, the monster scanner could be a similar thing as a phone, because it has a screen, a touch screen, and it scans for monsters that are close to you. But it uses the same raw materials that we would need in a phone. So it needs a battery, it needs different types of raw materials that you would need for a screen and so on. There's also a jetpack that uses lightweight metals and so on to be used and so on. So this was something that was really interesting for the kids, especially that they could find new items and build them with raw materials that they find. We also added some geological processes. So there's, for example, fossils, slow geological processes that conserve fossils for us. And there's also some weathering processes that take place in pegmatites and limestone and so on, connected to water. So in the picture behind here, you see that limestone, when it's connected to water, it actually weathers over time and will break down. So it's not really great to build with close to the water. There's also something called the achievement system, which is a system that we built to track your progress in the game. And for example, if you're aware of games in general, it's something that's usually found. But just to give you a quick overview, you could you tick these boxes really in this tree. So as an example, to the left here, we find a mineral first called feldspar. With the feldspar, we build a smeltery, and we tick that box. With the smeltery, we build then an alloy furnace, or we take some ores and we refine some metals, and then we build an alloy furnace, and then we build something else and something else. So it's something that we use for educational things. For example, a teacher could say that, okay, I want to see you come three parts down in this achievement tree, and then explain the steps from raw materials to product, for example. We also added books in the game. There's a book in Swedish, but there's also books in English and Italian and other languages. And when you find a new metal or find a new ore or a new soil type or something, you get a small book that explains some things about how it looks in the real world. So, for example, here it's a book about brass and how it works and looks in reality. So just to give a short summary, BetterGeo, the modification, it's a modification that introduces realistic geology and raw material management in Minecraft. It's been developed since 2014, and we are now working on further updating it. And it's free to download, so you can download it easily for yourself. And it's been something that's been really successful, really. But okay, this is cool and all, but what if we don't have computers? Is it useless? So I would say no. I know one of the problems with teaching with games and so on is that it's very difficult to get computers, to sit down in a place where you have a lot of computers and so on. But I believe that gamification it could work both online and offline. And because many people love Minecraft, it's something you can really use, like game elements such as in videos or printed material and so on. And I will show some of those examples later. So we've been using this modification in a lot of places. One thing that we've done, for example, with offline activities are the thing you see here. So here, standing with some people that are doing a rock memory game where we have real rocks, different ores and rocks, and in front of them they have very small pieces of paper where there's a picture of one of the rocks in the game and the name. And their task is to take the paper and match it with the same rock. So connecting the game to the real world. And if you know Minecraft, the blocks that you find in Minecraft, they are 16 by 16 pixels, so they are very very rough in the nature, and but they can still, like many students, they can still see like the rocks that they find in the game. They can still match them with real rocks because the graphics are still that good enough to do that. So that's something that we've done, and this is actually the same thing at another a few other pictures where we've done this. This is also in Slovenia. We've done the same. Again, the pictures of the rocks and the real rocks up in the top right corner. Yeah. We also did some integration with museums. So the Museum of Technology in Stockholm in Sweden has been using this modification in their exhibitions, which has also been quite successful. And just to show that the modification has been used worldwide. So a few years ago, I got contacted by a Japanese colleague that I didn't know from Fukuda Geological Institute, and they asked if they could use this material in some sort of geology day or something. And I said, fine, it's go ahead, use it. And I didn't hear from them until a few weeks after, where I got these two pictures where they actually made a roll up with different pictures from the game and real rocks and so on, and there's kids playing the modification and so on. So we have users from all over the world, and right now there's over 50,000 downloads of this modification. So and there's also been quite some media around this, but one of the most important ones, I would say, back in 2016 was this article at a big news site called geek.com that said that BetterGeo turns Minecraft into an immersive tool for teaching geology. And we realized that, or we had realized for quite some time, that it would be a powerful tool to also use in schools, something that we could actually take to schools and give to teachers and help them to give out lessons about raw materials and sustainability and circular economy and all of that with Minecraft. So back in 2017, we started a pilot called BetterGeo Education that set out to do unique, innovative educational material about raw materials. It should be easy to access. It should be free. We did complete exercises with installation guides and teacher handbooks and extra materials and so on. It was made for a lot of different languages, and it was funded by EIT Raw Materials, and is now available on the bettergeoedu.com site. And I'll show you a bit more right now. Just to give a, like in the beginning, we made especially one exercise that was a bit longer made for primary school, where kids were supposed to play the game. First, it was set out in two parts. So the first part was the kids were set in a computer room where they played the game, and they were set out in pairs of two, and they found themselves in the game and in different types of rooms. And in these rooms, they found different rocks and minerals. And one person played the game while the other person had a sheet of paper where they sketched out the different rocks and then wrote down the name of the rocks and answered a few questions. For example, how hard is the rock? And to find out that information, you were supposed to take your pick and use it on the rock and count the seconds it took to break it. And there you could get a number and understand how hard the rock was. And that number actually goes back and replicates quite well to Mohs hardness scale, which is a scientific scale that we as geologists use. So after they sketched all the rocks and minerals in this exercise, we took away the computers, and then we looked at real rocks. So they got a few samples of rocks, and they were supposed to identify the rocks together with the sketches and experiments they made in the game. So, and it was actually quite easy for them to do, even though the sketches and the made from the game were quite easy. They could use such things such as texture, color, hardness, and so on of the rocks, as we do, like real geologists do also. For example, there were two rocks that were quite similar. One was a gabbro and one was a limestone. I mean, for a 7-year-old, this is quite difficult to differentiate. But one is very soft and one is very hard. So using the two rocks together, they could scratch them against each other, and they would see that one of them would get scratched and one of them would not be. And the one that would be scratched would be the softer rock. So it would be the limestone in this case. And it helped them to realize some tools we as geologists use to identify rocks. We also did some train-the-trainer events for primary school teachers, and I want to say that we are available for such train-the-trainer events even now. And we are here for 1 hour now, and it's especially made for teachers. So, but we do longer train-the-trainers also to help teachers to get used to this, because we know that some teachers are hesitant to use games in the classroom and so on. So it could be something that is very important. So this ended up as Better Geo Education. It's in essence, it's a website where you can find different educational material. There's installation guides and so on and so on. And I thought that before we end, I go through some of the educational tools that we have, some of the exercises, just to give you a short run through. But remember to ask questions in the chat if you want to. I see there's some questions in Italian, but I don't know Italian that well. Maybe I can use Luca to translate for me.
No, they are joking.
Okay. So for BetterGeo Education 2.0 is actually an EIT raw materials project, a EU project where we are 8 partners. Together with the Italian partner, we are in Ireland, in Austria, in Estonia, in Slovenia, in Spain, and in Belgium, and Sweden, of course, leading. So just to give you a short run through of some of the educational tools that we have, some of the educations, these are available on the website with step-by-step instructions. There's installation guides and all of that. One of them is the rock memory that I showed before, where you actually, it's a very simple and short exercise that you use in a very short amount of time. You identify real rocks using pictures from the game and so on. There's the rocks and minerals exercise, which is a much longer exercise where which I showed, where you play the game and identify real rocks in 2 parts of the exercise. This one requires computers and rock samples, so it requires some things, but it's a very good exercise. Another thing that it doesn't use computers is the Lithium battery bingo, where it's actually a classic bingo game, essentially. And you have these bingo tables or boards, which are crafting tables from the game. And your objective is to find raw materials to build certain items in the game. So different players or different teams have different items, and the teacher brings up different raw materials, and you're supposed to build your item with the crafting table, such as in a bingo game where you would draw numbers, but instead you draw raw materials. And this only requires printed things, so it's much easier to use. Another thing is Lego mining, again for the ages to 7 to 11, basically. Also quite easy to use. You only need some Legos, and you actually illustrate how metals are extracted from rocks using pictures from the game and using Legos. And you're supposed to follow the steps from rocks and extraction to processing and recycling and so on. So it's quite easy. There's some presentations that are available on the website also that you can use. A new exercise coming out soon is raw materials and earth science. It's a exercise that is built to do at home now that many students are at home, where you actually can. There's a lot of questions that are given to you, which you need to explore in the game. For example, which types of minerals are in different rocks and so on. And you can either play the game or watch videos of someone else playing the game if you don't have it yourself. And it's a highly adaptable exercise that you can use either in the classroom or like a homework or project, for example. Another one developed in Slovenia is the Rocks to a Computer. And it's basically a storytelling game where students sit in a classroom and there's a story being read up. And during the story, you get to know about different types of raw materials and different types of tools that we see in the game. And they need to put down almost like a memory game with in the story. And that have almost like a board in front of them. So it's also a exercise you can do only with printed material. The last one I think I have is BetterGeo Hunt. It's almost like an orientation game within Minecraft, where you are supposed to orient yourself in a certain world in Minecraft and find different things and answer questions and so on. You have a compass and a map and so on. And you can basically, it's used for analyzing the path from raw materials in the circular economy. So thank you very much. There's 13 minutes left. I feel like I've been speaking for a very long time. I would like to open up for questions if you have any. I see there's one question now, but if you have more questions, please write them in the chat now, or if you want, you can also unmute yourself and ask questions or raise your hand or something. I see there's one question now from Christian, which is, how did you manage to keep the basic rules of the game? And I guess the basic rules still apply in the game. There's no difference there. The game is still Minecraft. We just changed some of the rocks and some of the blocks and added some new items and so on. So the game is still, the rules still apply, I would say. I know Luca has been very successful in Italy with running some of the exercises together with schools. So it's nice to see.
Okay, there is another question.
Yeah, is Minecraft a game with many possibilities? Yes, I would say that it's almost endless possibilities. As it is built to really enhance the creativity of the player, you can really build almost anything, and you can create a lot of things. And I think using the game as an educational tool could be very good, because there's so many possibilities. I know I showed a lot of different exercises now, and there's even more that we have, and there's a huge amount of possibilities here to work with. Where can we download the modification? And do you actually play your Minecraft mod? So I'm writing down a website here where you can go. Thank you, Luca. There's a website there where you can go in, you can find the installation guide and you can download it. It's free to download. You need Minecraft before to play it, but the modification itself is free. If I play the Minecraft mod myself, I don't really do it that much, but we have been, because there's difficulties to meet people in real life, we have been streaming our game on Twitch. And if you want to go see us play BetterGeo on Twitch, I recommend you searching for BetterGeo Edu on Twitch. I believe it's twitch.tv/BetterGeo Edu if you want to go look. So Andrea asks if is it possible to insert some media content like short videos inside items found in the game, like books, etc. And I don't know. I got that question before, and I think that it should be possible, but I'm not quite sure. You can insert like text and all of that. That's no problem. But I think that it should be possible to run some kind of videos or photos or something, but I'm not sure. It requires some additional knowledge, but I don't have today. We have a programmer working together with us in the Geological Survey of Sweden that might know. But if you email me afterwards, you can maybe ask like that. I'll post my email now in the chat, lest you have any more questions. On what version of Minecraft does the mod work? So the version right now that works is 1.7.10 and 1.12.2. We are working to update the modification to a newer version next year, and we are also taking in some new features into the modification. So yeah, there's that. There's a question of how are you? I'm very well, thank you. Did you help to program yourself this Minecraft mod? Yes, I did not program that much myself, but I did. I was present in the development phase. We have a programmer working with us that actually did the programming of the game, but we were several people working with the ideas and so on. Which age group was it intended for? And I think all ages can play and have fun with Minecraft, but I think it's mostly within the primary school age. Really. I don't see any more questions coming in, so I will end here. And thank you so much for joining in on the webinar. It's been really great to get all these questions and to see that we were so many people joining in on the webinar. 88 people. That's a lot. It's very good.